All right, now we're going to get into isosceles trapezoids. So isosceles trapezoids have 4 different properties, including, and it includes the angles that aren't base angles being 180 degrees that we learned from trapezoids in the last video. Okay, so we have one pair of parallel sides, so that's these sides right here, parallel. All right. We have legs that are congruent. So if you notice, I put tick marks on my legs. Those are congruent to each other. Diagonals are congruent. So this diagonal is congruent to this diagonal. They are not bisectors of each other. Notice how this segment right here is a way smaller than this one right here. So what it is from corner to corner, they are congruent to each other. And then base angles are congruent. Okay, so in the last video, we learned that if they are not base angles, they add up to equal 180. Well, now if they're an isosceles triangle, the base angles are going to be congruent. So if they belong to the same parallel, these angles will be congruent. If they belong to the same parallel line, these angles will be congruent. Okay. All right, let's go into our examples. In example 1, it says ADC is 54. So this one is 54 degrees, and it wants to know what BCD is. Okay, well, if this is an isosceles trapezoid, okay, notice how the angle it gives me versus the angle I want belong to the same parallel line. They belong to the same base. Therefore, angle C is also 54 degrees because base angles are congruent. All right, so let's kind of forget what we just did, okay? 54 is no longer in the picture, but it tells us that BAD is 112. And it wants to know what BCD is again, okay? Well, let's think about this. 112 belongs to the top parallel. BCD belongs to the bottom parallel, okay? Meaning they're 2 different sizes. AB are going to be congruent to each other. CD are going to be congruent to each other, but they're going to be 2 different sizes. Okay, they're going to be 2 different sizes. Therefore, angle A and angle C are not congruent to each other, but they add up and equal to 180. Okay, so that means 180 subtract 112 will get us our answer. Okay. Another reason why this works is because angle C is congruent to angle D, and angle A and angle D belong to the same leg. Therefore, we know for sure that they are supplementary to each other. So 180 minus 112 will get us 68 degrees. All right, let's get into some examples about angles. Okay, it says that the measure of angle EDO is 110, and the measure of angle DEN is 15x minus 5. Okay, so then we need to determine, do they belong to the same base, or are they supplementary to each other? So angle D belongs to the base that I have highlighted in pink, whereas angle E belongs to the base that I have highlighted in green. Therefore, they will add up and equal to 180. So 15x minus 5 plus 110 will equal 180. Combine these, so I'm left with 15x plus 105 equals to 180. Subtract 105. I'm left with 15x equals 75. Divide by 15. And x equals 5. All right, on this last example, I'm not going to physically do it for you, but I am going to help you set it up, and then I'll put the answer into the description below. But it says PR is 3x minus 7. And it says that TA is 20. So if we go back to our property rules, we learned something about the diagonals, and it says that the diagonals are congruent. So therefore, when we're looking at this problem, we know, because diagonals are congruent, that PR is congruent to TA. So then we just set it up that way. So PR has a value of 3x minus 7, and TA has a value of 20. So then you just solve for x. Again, description will be below. All right, guys, go straight to the teacher-made assignment and complete those practice problems, and you are good for the day. Bye, guys.